In this video, we're going to introduce you to the basics of using OpenCV in a simple color detection program. OpenCV is a library of programming functions designed for use in real-time computer vision. A simpler version, known as EasyOpenCV, is more commonly used in FTC to analyze feed from webcam and collect data about the robot's surroundings. The three main steps of getting started with OpenCV are downloading the library, initializing the camera, and writing a pipeline. The first step is downloading and importing the EasyOpenCV library into your Android Studio codebase. First, open your FTC Android Studio project. Navigate to the build.gradle file in the Gradle scripts module and paste in this statement. Next, go to build.common.gradle and remove any references to ARM64-V8A, if there are any. Then, perform a Gradle sync. Finally, you'll have to add OpenCV repackage to your control hub. To do this, download the .so file from the repository linked in the description. Plug your control hub into the computer and copy the file into the first folder using Android file transfer. Now, you are ready to begin writing code. Camera initialization is slightly more complex than the initialization of other hardware devices. At this point, you can open Android Studio and create a new Java class. Set up the code for a basic auto with both an init and loop function. Make sure to declare your webcam as a class member using the following format. In the init function, create a webcam name variable and map it to the webcam using the name in your configuration file. Next, copy this line of code, which will automatically retrieve the ID of your webcam. Set the pipeline you want your camera to run with. A pipeline is a set of directions that tells the webcam what to look for in the live feed. For now, we will use a placeholder and we will write the pipeline later. Using this block of code will open the webcam. In the case that the webcam is successfully opened, we want to start streaming the camera feed to the driver station. The parameters of the start streaming function are stream width, stream height, and stream orientation. In this example, we are using a 640 by 360 camera in an upright rotation. We have successfully initialized the webcam and can now start work on writing a pipeline. Create a new class that extends OpenCV pipeline. Make sure the name of your pipeline matches the name referenced in the setPipeline function. This is also where any variables that are members of the pipeline should be defined. Within the pipeline, add another function called processFrame, like so. Our pipeline is going to detect the general location of a red object in relation to the robot. To do this, we're going to divide the screen into the desired bounding boxes. This step is going to depend upon the streaming resolution of your camera. I'm using a 640 by 360 stream, so we are going to divide the frame as such. You might have to divide yours differently depending on your camera's resolution and what you are trying to accomplish. To actually create these bounding regions in Android Studio, simply create a variable with a type rectangle and the following parameters: X location, Y location, width, and height. I'm going to create two of these boxes to divide the screen evenly. Please note that all variables, including rectangles and matrices, must be declared in the beginning of the pipeline. Also notice that we've converted the feedback from the camera from RGB to YCBCR for the sake of coding simplicity. Using these two lines of code is optional. However, it will allow you to see your bounding boxes if you choose to stream to the driver station phone. This can be a very helpful feature for debugging. Next, we will create two crops or submaps of the camera frame using the boundaries of the previously defined rectangles. Since we're trying to identify a red object, we want to extract the red channel, in other words, remove all other colors from the equation. When using extract channel, the parameters are input image then output image, which are the same in this case, and then a number between 0 and 2. This number tells the robot which channel to extract. Since the camera is streaming in YCBCR, we want to extract channel 2, which is red. Then, to find out how much red is in each submat, we will take the average of that extracted channel. Our final average value is equal to the first digit of this scalar. Finally, we can use logic to compare the average values from each region to determine where our object is. Thank you for watching, and feel free to reach out with any questions.